Okay, have a look at the level 2 exercise. It's just a wee bit more wordier, but it's the same principle. So it's pi your y squared. And remember, power to power, you multiply them. So write that as 2x. Then to integrate that, you must have the derivative in front. The derivative is a 2. Pop it in front. Put your half outside. That's good to integrate now. So the derivative disappears, and you're left just with your e to the 2x, and that bit outside. Sub in your 1, sub in your 0. Number 2. You have started off, write out your formula. Your y is k squared. Now what you're likely to make a wee mistake in this one is, make sure you square your k. So it's k squared x squared. Add 1 to the power, divide by it. I just popped that k squared outside the integral sign because it is constant. It doesn't have an x in it, so you can do that. Sub in your h and sub in your 0. Now, in this next one, find the deduce the formula for the volume of a cone with height h and base radius r. So your radius is kh. If you look at the wee picture there, you know, if you can imagine spinning it around, this is your radius, so kh. So I could rewrite that as k is r over h, and just sub that in here. So it's a third pi. Your k is r squared over h, so square it over it, and then cancel it down. So your h3 and h2 cancels. Number 3, so you're going to find the volume of this. So there's your y. That's straightforward enough. Bring that up as minus 2. Integrate, sub in your values. Number 4. Okay, so here's our curve, e squared minus 1. Now, if you are not comfortable squaring that in your head, do feel free to write it out the long way. You know, so that's ex times ex minus ex plus 1. Multiplying two numbers, add the powers, so e to the 2x. Take away 2ex's plus 1. Or you can do it the quick way. Square the first, so e2x, because remember, this squared, a power to a power to multiply, so it becomes e to the 2x. Square the last and double the product. It's just whatever's more comfortable for you. You may prefer doing it out the long way. Now you can see me splitting them up into separate integrals. So that's the first one. The second one, I put the minus 2 out, and then the last one. You need to have this balance with the 2, so a half outside, and then you're good to go. This one, the derivative is a 1, doesn't need any balancing, so it's way to go. And this one, just the x reappears. Sub in your log 2s, sub in your zeros. Want to look a wee bit at what happened when I subbed in the log 2. See if you sub in your log 2, you get e2 log 2. Remember, one of the rules of logs is the power can go up to the top. So this is the wee rule I'm using here. So log ax, you can bring your x to the front. So what I'm doing here is I've got 2 log 2. So I'm basically bringing my power back up again. So that's log 2. So log 2 squared is 4. E to the log disappears, so it's a half times 4. This one here is more simple. E in the log disappears to give you a 2, so it's 2 2's, and that one's okay. So just a tidying up of that. And the last one we have to look at, the ellipse has this here equation. So first of all, do you remember inside your wee formula is y squared? So you've got to rearrange this to get y squared. That's what I've done there, okay? So basically I went down to y and then squared. Again, you don't have to do that. You could just go y squared here. So pi in front, don't forget your pi. And you're told at p and q, y is 0. So put y to be 0 and solve this wee equation out. So you've got your 2x values, 2 and minus 2. So that's your wee integral signs. So integrate, sub in, tidy up, and make sure you multiply by pi.